Hello, hello, everyone. Awesome.
Hello. Hi.
How you doing?
Is it good? Is it live?
Yeah, should be live.
Okay. All right. Should we intro first?
Should we just get into it, or should we do an introduction first?
Okay. Maybe you can start first.
Okay, sure.
I'll be after you.
Right. Yeah, it's been a few minutes now. Okay. So welcome, everyone. This is going to be our Indonesia-focused workshop. So I'm Robert. I'm from the US, but I'm happy to join you all. And today I'm just going to be talking about just a lot of things relating to crypto, privacy, AI. I'm going to try to stay pretty high level, not go too deep into the weeds, but I want to be able to give people an idea of what Oasis is all about, what motivates us, and how you could learn more ultimately and kind of join us in our community. So yeah, like I said, I'm Robert. Joined here by Rickson. If you'd like to introduce yourself.
Okay. Hi, everyone. My name is Rickson. I'm from Indonesia. I'm from Jakarta. So today I will share to you guys how I can make products with Oasis protocol before. I joined two of hackathon and we won using Oasis protocol. We make a product. It's called Squidl. So yeah, maybe I'll share about that and maybe share the experience of how we make the products and how Oasis as the protocol can help us and we can make more things with the protocol, Oasis protocol.
All right, awesome. And yeah, it was really nice at the Singapore ETH Global Hackathon to see all these kind of new projects building very novel things. So Squidl was very exciting. So yeah, thank you for joining us ultimately.
Sure.
All right. Yeah, if there's no other to-dos, I would say let's get started then.
Sure.
So like I said, I'm Robert. I am a BD specialist with Oasis. So my focus is mainly on building our ecosystem, providing support for projects, connecting people together, and really trying to help people understand, what the value is with privacy as it relates to crypto and also AI. So I often attend conferences, hackathons, that sort of thing, but also work, remotely with a bunch of projects to, get them deployed on Oasis and build something new, right? So what I want to focus on today, like I said, privacy, crypto, and AI. All of these things can relate to one another, but the goal is to have all of them at once, ultimately. AI, maybe, not every use case is going to need AI, but we see how powerful it can be lately. And so I think it's definitely something very important to talk about, in the current year. AI is moving extremely rapidly, just like crypto moves extremely rapidly. So for now, I'll just focus on the crypto part so we don't get too out in the weeds already. By crypto, what I really mean is blockchains. So for blockchains, what is all the fuss about? So the technical definition would be that you have this distributed digital ledger. It's securely linked together by cryptographic hashes. We have all these terminologies, but what do they mean? Distributed, we just mean we have the system. It's replicated across many machines around the world. It's not just a single centralized server. It's not just the cloud. It's many machines all running the exact same piece of workload. A ledger is just a way to record and come to consensus about some kind of data, maybe some kind of computation. And then ultimately, it'll permanently store that so that anyone can view it in the future. And a cryptographic hash is just a way that this system can remain tamper-proof. So there's cryptography and math involved, and this is implemented in various ways depending on the blockchain, but they all tend to use some sort of cryptographic hash. Otherwise, it wouldn't really be called crypto. Okay, so what are a few examples? If you're familiar, or if you've heard of Bitcoin, perhaps, that's one example. Ethereum would be another example. These are pretty well-known names. And also Oasis is an example of a blockchain, Oasis Sapphire specifically. So I talked about kind of the technical definition, but what are the key features we want to look for with the blockchain? The first is typically we want it to be permissionless. We want anybody to be able to participate in the validation or the usage of the network. And we want it to be decentralized because we don't want anyone to be able to cheat or change the consensus, by their own means. We want large groups of people to be able to come to consensus, but we want them to do it fairly. And we do want it to be transparent in a certain way. Transaction data is visible to the public, so anyone can actually verify that computation was done correctly. We'll see in a second that there's exceptions to every rule and caveats, but transparency is kind of a big thing in the crypto space. I know this is to talk about privacy, so let's talk about those exceptions. We have permission blockchains, which they can do things like whitelisting validators, and so this is popular with more traditional financial institutions where they have to comply with regulations and they have intellectual property and that sort of thing. So we can see already that the Bitcoin ideal is maybe not always going to be implemented the exact same way. There's also sometimes certain degrees of centralization. Different blockchains will have more nodes or less nodes due to scalability requirements or other reasons. And there's also private blockchains, which you can allow for the transaction data to be hidden from the public, or encrypted would be the more technical term to use. And Oasis Sapphire, which I will talk about, is essentially one of those blockchains that it gives you the option to have encrypted smart contract data and transactions and that sort of thing. So there is this kind of trilemma of scalability, security, and decentralization. And so that's why there's all these caveats and trade-offs, but ideally we want to get the max ability we can out of our blockchains. And the space has evolved a lot in the last 10 years. So it's not the same, systems of, it's not just Bitcoin and Ethereum now. We have a lot more potential use cases and really cool implementations. Okay, so that was crypto. And now I'll go into privacy very briefly. So why do we care about privacy? Well, from a philosophical or ideological perspective, it's a fundamental human right. And I think a lot of people will agree with this. But we've also seen more practically that as the internet has grown, so has the scale of data breaches and hacks. And so with that comes, the leaks of our data. So this can happen in healthcare, but it can happen in a lot of other industries as well. And we've seen some pretty massive data breaches. There's actually more on this bubble chart here that are not visible, but I won't go into specific names all over the place, but there's been hacks that have affected billions of users. And so that's something that we should all pay mind to, that every one of every single user that uses any sort of website has the potential for their data to be leaked in the future. And so we should think about, what are the consequences of that? So that's the motivation for privacy, but what are some ways to implement privacy? Well, Oasis is a project that specializes in TEEs, and this is an acronym that just stands for Trusted Execution Environment. Okay, but what does that mean? It's pretty complicated. So there is a paper online called Intel SGX Explains. You can Google it for yourself. I've included the link here. It's 118 pages long. It's a very long PDF, very involved, and I'm not going to pretend to understand it fully or expect anyone listening to this right now to be able to understand it. So maybe we could simplify things a bit. If we want to simplify things a little bit, we could say that with this trusted execution environment, we have some apps that are running on some machine, and part of that machine is going to have these protected hardware resources where we can run our apps. And this is somehow going to give us privacy in our applications. If we really want to simplify it, because that still was a little complicated, we could just say that a trusted execution environment is a black box for computation, and that gives us privacy. So we take some input, we do some computation or some change to it on a machine, and it gives us some output. We don't have to worry about the details that go on inside of it that makes it private. And this will use hardware level isolation. So this will either be the CPU or the GPU or both. And the magic sauce behind it is attestation mechanisms, and this will give us verifiability. So again, you don't have to understand the details of how this works, but this is very important for it actually functioning. And I'll mention this again in a bit. So that's basically crypto and that's privacy, but what if we combine the two, right? That's kind of the next logical result. Why can't we just stick these two things together? And we have done exactly that. So Oasis has built a blockchain that uses these trusted execution environments, and you can use them for smart contract execution. So it's no longer this fully transparent blockchain like Ethereum or Bitcoin. Ethereum has smart contracts, and Oasis Sapphire is a confidential EVM. So it's very similar to Ethereum in that way, but you have the ability or the option to encrypt your data and therefore get encrypted results. And that can be very powerful. So yeah, like I said, Oasis Sapphire is the first and only confidential EVM blockchain in production. The more technical aspect is that it uses a network of nodes, and they all run this Intel XGX I mentioned in that paper earlier. And what that gives you is the encryption of transactions, call data, and smart contract data. Okay, so this is all the technology behind it, but what can we actually do with this, right? We care about privacy. We see the value in it, but how do we wrap our heads around what this means for the future of crypto, the future of Web3? Well, some of the straightforward stuff would be DeFi with added confidentiality. You can have swaps that are private. You can have lending and borrowing that is private. And in the case of lending and borrowing, this can give you things like hidden liquidation thresholds. If anyone here is more involved in the DeFi space, if you've ever taken a loan out on Aave, for example, or any other lending protocol, it's possible for the price of assets to be manipulated to cause the liquidation of users. And this is maybe not happening all the time for everyone. It depends on a lot of factors, but it is a possibility. And so hiding that liquidation threshold could be desirable. Another really interesting use case, in my opinion, is DAOs and voting. So there's plenty of DAOs on Ethereum now. As the societies, we tend to value voting pretty highly in general to make decisions on things. And on Ethereum, for example, any DAO vote that occurs is going to be public. And maybe we don't want all of our votes to be public. Maybe we just want the results to be public, but we want our individual votes to be private. And this can be to a variety of reasons, but it can include not wanting to, incentivize coercion, bribery, that sort of thing. So we want to try to replicate systems that occur in the real world, right? We have private elections, for example, in the real world. So we want this to be something that's at least possible on a blockchain. So we built this. We built BlockVote, and you can go to it today, vote.oasis.io. And basically, it has all these nice features, which I'll get into, and you can do private votes. Another pretty interesting avenue is gaming. So on-chain gaming is maybe not a huge space, but it definitely is a space that needs privacy because any game in the real world, any game in a web, online in Web 2, often you'll have some sort of riddle or you'll have some sort of puzzle or some sort of secret involved that makes the game interesting. And doing that on-chain is difficult because now you're publicizing all the secrets before anyone even discovers them. But if you have a blockchain that supports privacy, this is no longer an issue. So let me get into BlockVote a little bit. I just want to dive a little bit deeper into this. So we built this app. You can go to, again, vote.oasis.io. And you can see here that it's pretty straightforward. You can create a new vote. They're called polls here. You can explore polls that other people have made. And when you do that, when you go to the creation, it's just a very straightforward interface. You enter your question, some description, possible answers, and then you can go into the pre-vote settings. And this is where the kind of on-chain aspect comes into play. And there's a few different ways you can constrict who can vote. For example, you can do token snapshot voting, where it looks at a certain contract address on a specific chain. So it's not just limited to Oasis Sapphire. And so you can say, okay, only NFT holders of this specific project on Ethereum mainnet are able to vote in this DAO vote, for example. And you can configure this however you'd like. You could adjust the weight of the votes. You could say it's going to be linear, proportional to the number of tokens, or it's going to be quadratic, or these sort of things. And then there's also gas sponsorship. So if you have users on another chain, they're probably not going to have Rose, which is the gas of Oasis Sapphire. And so to reduce friction and be able to onboard users as efficiently as possible, you can actually just pay all of the gas up front for a given pool of users. And then they could just click sign a transaction in MetaMask, for example, and that will allow them to have this vote. And then all the results can be aggregated and then sent back to the home chain, and you can get your results. So it's pretty nifty. I really like the way it's been designed, and I think a lot of people should hopefully see use in this. So this is just DAO voting, but this is just one example. But I hope this gives people a concrete idea of what you could do when you add privacy to pre-existing things. So like I said, we have these on-chain use cases, but what about AI, right? I mentioned that I want to talk about AI in this talk. AI has been a very big topic lately. How can we maybe integrate AI with the rest of crypto and privacy and all this stuff? Well, first, let's just think about what we mean by AI, right? So typically, lately, it's been large language models. It's been chatbots, ChatGPT, Claude, DeepSeek now recently. So, all these names have been flying around, in the Twitter space. And, these can provide a lot of utility for people in a lot of different ways. You could also do things like image and video generation. Midjourney would be one example of that. And then when you get more specific, there can be productivity tools that really don't fall into either category, but let you do, things that help you with your work, for example. Maybe it's specific to a trade or a profession. So AI is basically just this kind of productivity generation, area now, at least in common knowledge, right? There's a whole deeper area of AI, but we don't really have to worry about that for the sake of what I'm going to talk about here. Okay, so how do we get on-chain AI? Well, these large language models like ChatGPT or DeepSeek, they require GPUs for training and also inference, which is just producing some output when you give it a prompt. And those outputs are non-deterministic, and that means that they aren't necessarily the same each time you give an input. So if I give the same input over and over, I'm going to get a slightly different result. And they're also compute intensive, meaning it costs a lot. So if I have this blockchain that I'm running on a bunch of machines, then I have to do this expensive computation over and over and over again across all these machines. And that's going to probably not work too well. And then there's the added issue that blockchains are by design not meant to access the web. And so you would need some sort of trusted oracle to relay information from the web to your large language model if it were running on chain. This is not necessarily an impossible hurdle, but you can see that all of these provide significant challenges to just sticking an LLM on a blockchain and letting it go. So maybe we got ahead of ourselves. Maybe worrying about AI and crypto is maybe we moved too quickly. So maybe take a step back. What about the private aspect though? Because even if we can't get the crypto part, maybe the private part would be good enough. So maybe we could just take our AI and just run it off chain like we normally would, stick it in the cloud, right? There are centralized cloud providers that offer the use of these trusted execution environments, and so in principle, you could have AI, which is private. The AI runs in this black box. The company or the cloud provider that's running the service can't actually see the things you're prompting, so it keeps your data private. It seems not too bad. So, the examples would be Google Cloud, Microsoft Azure. These things already exist. Question is, though, can we trust them? It seems to me that I don't really think we want to. It would kind of defeat the purpose of, all of the things that we've done in crypto if we could just say, run it in the cloud. For certain use cases, maybe you can, and that's fine. Not everything has to be on a blockchain. Not everything has to be in a TE even. Not everything has to be private, but there's going to be reasons, there's going to be times where you don't want to trust these large services. And so we probably do want something better. And it'll beg the question, why use blockchains at all, right? We need to understand, why are we doing this in the first place? And that was why I started this talk motivating, what are the key features of blockchains? Why do we care about them in the first place? And one of those aspects was verifiability. So when as it applies to AI, how do I know that I'm receiving outputs from a model that I actually paid for? Maybe I'm getting outputs from a different model and there's no way to prove it. How do I know that my data is being handled appropriately? I talked about all the data breaches and all the leaks. I want to know that it's not going to be leaked. That's very relevant to me. And finally, how do I ensure liveness? If I'm using an application, maybe as a consumer, I don't care too much. If a website goes down, oh, okay, I'll check back later. But if I'm a business and I am using a specific service and that is integral to the rest of my business functioning properly, it's going to matter a lot to me that this is the best liveness that it could possibly have. If a website goes down, for example, ChatGPT going down, it might cause me real problems. So how do we fix this? I want to know, am I getting what I paid for? I made a chart here, very straightforward. It's just the cost on the vertical axis here. You don't have to worry about the units. It's in dollars per million tokens, but just think of it as, cost in dollars essentially. So for a certain workload, OpenAI's O1 model costs $60. There's another model that is, open source, Microsoft Phi 4, and it's very cheap. It's only 14 cents. You see this goes off the chart at this point. So there's a big difference in cost, and you would expect probably one model is going to be better than the other. And so some people want to pay for the better model, and they're going to want to get what they paid for. In this case, the difference is a 400 times difference in price. So they're really going to care. But how do I prove that, I got what I paid for? Is there a solution? And I wouldn't be talking about this now if there was not a solution. So yes, we can combine off-chain computation. So like we said, it's almost like the cloud. We could run it in a TEE, and that gives us that privacy. And then we can use this remote attestation process to publicly post the proof on chain. So let's pause for a second. What does this mean? Well, when I say run it off chain, the goal is to have a scalable application. I want to be able to run this, very, very large workloads for as low cost as possible. When I say run it in a TEE, again, I'm talking about confidentiality. And when I talk about remote attestations, this is what gives us verifiability. I could just run a machine and tell you, hey, don't worry, I'm running your AI privately. Nobody can see the data. I can't see the data, I promise. But, promises can be made and broken all the time. Just making a promise that something is private, that's not good enough. And we should expect better. And so making it verifiable where anyone can prove, with this remote attestation process, that's really, where things get really powerful. So this is how we unify all of it. We'll have crypto, we'll have privacy, and we'll have AI, and we'll kind of put it all together. But it's not just throwing things together blindly, it's putting things together in a smart way where we get the maximal benefit out of each of these categories. Let's now talk about ROFL, which is what we are building. And this is an acronym. It does not stand for rolling on the floor laughing, although it does. But it also stands for Runtime Off-Chain Logic. So this is the off-chain product that we are building to support these kind of use cases like AI, but also while remaining private. So the idea is that you can have developers create policies, and then they could anchor these policies on chain. But then node operators, they could just take these binaries or these, Docker images or these specific pieces of code, and they could run them off chain and then just attest on chain that yes, I am running the correct piece of software. And so you're almost trusting them without having to trust them. It's quite nice. So yeah, you can have arbitrary software running containers, and what this means is you can have a normal program. It could just be something running on the CPU. Maybe it's some gaming app or gambling or what have you. But you could also combine this with the GPU and get real AI power out of it. So there's a lot of different possibilities. It's not just AI. That's kind of just the focus of this talk. So this is just kind of a general framework of how it works. I won't kind of go crazy, but ROFL is an intermediary in a sense between the on-chain world and the off-chain world. And it lets you do things like make queries to websites and APIs and that sort of thing. And yeah, it's this framework to get a lot more power out of our on-chain applications by having certain parts be off-chain. And so the question is then, if we can do things off-chain in a somewhat verifiable way, then why do we need Sapphire? Sapphire was the private blockchain that we built, right? Isn't that the goal? Is you have this privacy and you have everything on-chain? Well, some things still need to be on-chain. We don't want to just offload everything off-chain, because then you do lose some very powerful properties. For example, having payments and execution logic on-chain, that makes a lot of sense, right? You want users to be able to custody their own funds. And so if all that was off-chain, you're losing that property. So that doesn't really make sense. So we want some decentralized rails that we can build our applications on and connect them to, but we need a little bit of flexibility so that parts can be a little more feature rich. And so the idea is that we have confidential smart contracts on-chain, we have these off-chain TEEs, and if we combine the two, we get encryption from one end all the way to the other. So in principle, you actually get even more power out of it by combining the two instead of just using one. So this was a lot of, kind of theoretical stuff and architecture and that sort of thing and motivation. But again, what can we do with this? I talked about block vote for the on-chain aspect of, private smart contracts. What can we do if we're talking about off-chain? So let's think, for example, we have some autonomous AI agent. It could be running in the clouds. So let's say it's running off-chain, but if we put it as a ROFL application, it can manage an on-chain wallet, and it can keep the private keys of that, wallet actually private. There's a real question right now when we have these AI agents floating around. It's who controls the private keys? There's currently not really. I would say most AI agents out there, there's really no way to prove that the deployer or the person building the project, there's no way to prove that they don't control the private keys, and therefore there's no way to prove that they can't just sell all the funds, for example, and move it to their personal wallet. This is kind of a problem if we're talking about autonomous AI agents that have no owner, nobody that can control them. So we need to be able to prove and verify that the private keys are being controlled in a proper way. So with Oasis, you can have access controls and handle that with our decentralized key management, and this will essentially solve the issue. So that is one way to do it. But there might be another question that, what if we have this AI agent and the machine that's running it shuts down? Maybe the power goes out, the hard drive breaks. What happens then? We can create some workarounds. It's not on-chain totally, so we're not going to have this perfect liveness forever. But maybe we could spin up a couple extra instances of the same agent. And so we'll have a little bit of this replication, a little bit of this decentralization, but not the full thing. So maybe we can find a balance somewhere in the middle. So that was one use case. That was more theoretical again, but people are building these sort of things today. And another example, which is a lot more concrete and is actually, publicly facing being built right now, would be Simulacrum. So right now, a major pain point in crypto is wallet management. So for example, maybe some of you in the audience have experienced this. If you want to get into crypto, you have to download a wallet. Maybe you download MetaMask. You have to write down your seed phrase, make sure you don't lose it, make sure no one steals it. Then you have to go to a centralized exchange. You want to move funds onto it, and then you go on to all these websites. You're signing transactions you don't really understand. You don't know how to read smart contracts, so looking at the source code probably doesn't help. It's not very friendly for the average person. It's actually quite hard to get into without taking a long time to read and study and understand everything about how blockchains work. So Simulacrum is looking to at least partially solve this. particularly when it comes to wallet management. So there are a lot of account abstraction tools and solutions being developed. For example, you can have Web 2 credentials, like your Google account could be social recovery for a crypto wallet. So if, like I said, you write down your seed phrase. If you lost that, assuming it wasn't stolen and your money's gone, right? That's always a possibility. But maybe you just lost the piece of paper, you threw it out, the dog ate it, that sort of thing. In principle, maybe you could use your Google account to get those funds back. That would be nice. So that's one way to do it. But we can go a step further. And what if we had just social media posts themselves be direct actions on the blockchain? And as a user, I don't have to worry about how things are working in the background. I can just log into Twitter, make some posts with a certain format, and know that I'm going to send money from, myself to someone halfway across the world in Indonesia, for example, right? That is a big use case of crypto and blockchains, is just extremely low friction in sending money, across borders and that sort of thing. So imagine if I could do that with the social media post, that'd be even better. So they basically, they built this. So Simi, there's a lot going on in this image, but I'll break it down. So we have this automated Twitter bot, right? It's some sort of agent. It's talking to CZ from Binance, and he didn't reply back, but it is a reply, paging him. And it's saying it's not a bribe, it's an offer of cooperation. And so you have this agent that sends a tip of $500 to CZ, and it just uses this formatting. And this is all you need. You don't need to know about installing wallets. You don't need to know about blockchains. Once you have the funds associated with your Twitter account, you're good to go. So let's look at this a little more closely. So after this tweet is sent, we have a different Twitter bot essentially saying, hey, look, a tip was sent, $500 of ETH was sent successfully to this wallet account. So you can see this 0x49 here. That would correspond with the person that they tagged. So not just the sender, but also the receiver has a Twitter account that's associated with some wallet. And then if you care, you can check the on-chain proof that everything worked correctly. So yeah, we basically, if you want to know what just happened, because there's, again, a lot going on here, we had an AI agent make a post on social media. We had some executor, which you could just say is like a trusted oracle, create an on-chain transaction that corresponds to the specific phrasing that you used. And then they give you the transaction hash, which is the proof that this actually occurred on chain, and that the funds that you sent, they are custodied by that person now, and that it can't be reversed because this is something that we care about. And that's it. And then the money is sent. So Simulacrum actually indirectly kind of got big in the news. So AI XBT, which is a very popular AI agents. I know the AI agent narrative, maybe 2 months old at this point. So now it's essentially old news, but it's still a very big area of development. So I would not underestimate it. But yeah, AI XBT, for example, is a pretty popular one. I think probably the most popular one, if I'm not mistaken. And so this agent actually used Simulacrum to create a token. It was called Chaos. And so you can have this kind of autonomous world now where really you don't even need human intervention to be having this kind of crypto ecosystem launching meme coins, for example. These are not very insane groundbreaking use cases, maybe like, okay, it's launching a meme coin. But, think about how this applies to any other area of crypto. What if in the future we have agents that are using other services to create dApps and launch their own liquidity pools or launch whatever. This is kind of a watershed moment for AI and crypto in a way, at least the way the two intersect. So I found this very interesting, and this was actually featured in CoinDesk, so it got a pretty good amount of attention. But there is always going to be room for improvement, and so I've included the docs here for this specific project. But so it's not currently running as a ROFL app. We are working with them directly to get it running in ROFL. So we're doing that in testnet right now, and it does need a little bit more work, but the goal is to have at least certain parts of it running on mainnet in ROFL. And what that means is you'll have that kind of more autonomous nature, and that you'll eliminate that trust factor essentially. So you'll be able to verify, if an agent posting on chain is autonomous, which is really nice. Like I said, we're working on testnet right now. So the question is, well, when will ROFL be actually live? We do support on mainnet, at least partially, these Rust-based applications that use Intel SGX. But we want as many people to build as possible. So for that, you really want to support Intel TDX and plus containers. And so this has limited availability on testnet already. And so we're able to kind of work with projects directly and start to get them deployed on testnet and see how this works. But we do need a little bit more time on that. But then ultimately, we want to have much better documentation to fully allow people to not just work with us, but just go off and build what they want to build. And on top of that, having GPU support would be really powerful. So we did purchase an H100 NVIDIA GPU, and that lets us do our testing and kind of support people on a one-on-one whitelisted kind of basis. But again, ideally, we have some sort of data marketplace where anyone can come and pick their service provider, pick what app they want to run, stick it all together, and they have this just fully autonomous system. So this is, in a sense, our roadmap for this year. So that's really all I have to say. So like I said, we combine crypto, we combine AI, and we combine privacy. And when you do all three, you can get a lot of power out of it. But this is just the beginning. So I want to thank everyone for listening. I want to thank my team for allowing me to present here. And before I go, I just want to give a heads up of all the different programs that we have running. So if you'd like to join our Indonesia Telegram group, I have the link here. We also have a Sentinels program, which is essentially our ambassador program. I would recommend applying and joining if you would like to get involved more in Oasis, prove yourself, provide value, and kind of, reach other people and be able to educate other people about, what can Oasis do and, why is privacy important? Because fundamentally, I think anyone that gets involved in Oasis really cares about privacy. That's the main reason we're here. We also have a couple other programs. We do offer grants for projects. So if your project is looking to build, develop, deploy on Oasis Sapphire or build with ROFL, feel free to get in touch. You'll probably be forwarded to me at least half the time. So we can work directly on that. And then we also have a university program. So we're trying to get more involved with universities and education and that sort of thing. Obviously here we're doing education. We want people to be able to understand why is Oasis important, but more generally, why does crypto and blockchain and privacy matter to 99% of the world instead of 1% of the world? So I know that was a lot, but these are all the different programs we have. Feel free to check any of them out. I believe we will also be running a guilds campaign after this. So please join the Telegram and you can kind of see that and get involved in that. And that is all I have. So yeah, thank you for your time.
Nice presentation, Robert.
Thank you.
Okay. Should I just continue about my presentation was Squidl with Alzheimer's screen?
Sure.
All right. Okay. Hi. Good night, everyone. Good evening. So yeah, today I'll just explain from what is the product that I've built using like Oasis protocol. So yeah, I mean like Robert already like explained like how Oasis can like combine like the blockchain and privacy, and that's like the two things that I personally think is really important. So I'll share about like the products that I've built that we want to hackathon. Like one of it is like in Singapore, and the other one is like on Oasis hackathon. So the product is called Squidl. In short, it's basically a privacy static payment link. So our product is basically want to solve these three key pain points. There's a lack of transparency on privacy on blockchains, because like if we want to receive payments, we share our address and people can check directly what is like the activity on the address, how many assets we have, right? And there's like complex payment management. So even if we are only have like one address, but we are supporting like multiple chains, right? If we are getting payments in BSC, in the other chains in Ethereum, it's hard for us like doing the management. Even more hard if we are having payments also, receive payments in like banking, so in fiat platforms. And third is like there's a vulnerability in hacks. Once like we are exposed our wallets, there's a possibility that our wallets can be hacked if we are like doing connect the wallets here and there. So yeah, that's basically what's the problem that Squidl want to solve. Squidl is like privacy first platform. They're offering private static payment links that double as ENS address. So I'll explain like this is like the components of privacy focused payment solutions. This is like the features of Squidl. We are offering like private static payment links, so people can just share the private links, and it will become like the payment links for everyone that they want to receive payment from, and it will be all private. And we are using Oasis Sapphire integrations to make it like private. And we are also like using the concept of stealth address that is in Bitcoin, and we are utilizing Oasis ROFL to make our stealth address system. And we can support multiple chains also, and we are really want to make like all of these like hard or like sounds complex things as easy as possible for the users. So we are also want to make the UX is very seamless. So this is how like I break down how we are receiving payments right now, and I will like put it on like these four segment, like these four quadrant, right? So first, if we want to receive payments, we can get it from like MetaMask, like with decentralized wallet address. We make account on MetaMask or like Phantom, and we just share our address in there. And we can also like using our centralized access wallet, we copy the address and we share it to people that we want to receive payments from. And the third is like fiat bank transfer, is like just like regular payments through fiat or bank wire transfer. And the fourth is like we want to have like more privacy, so we are making new wallets for each time we want to receive payments. Like that's sometimes that we've done, right? And this is how we put it if we are put it on these four axes. Like we want to get a place where the funds is like fully self-custody and fully private. And the easiest and the way for us to reach this so far is like we are making new wallets for each payments that we want to receive. And how we can like make it more easy, right? Because like it's almost impossible for us to remember our address, and we have to like copy and make sure we don't miss any character in the address. And this is if I have to put where Squidl is places, that's the place. We are like self-custody and we are also very private. And if we are zoom in to the axis and we are put it on this axis, you can see like if we are using like make new wallets for each income, we can only receive from crypto, right? And we cannot receive from wire transfer or banking or bank. And it's almost impossible to remember our address. And with Squidl, it's easy to remember because we just have to make our own link. It's maybe just like a link tree, right? We can make like squidl.me/your name. So if my Squidl is like squidl.me/Rickson, and every time people open that link, they can transfer to me, and I can manage all the payments. And people cannot track what is like all the fund is going through because we are using Oasis. So this is how the fund is working. This is the concept of Squidl. So basically from the payments, we are supporting on Linea, Ethereum, Morph, and also we are using Dynamic for the login, and all of the funds, and we are using BSC also. And all the funds that we are receiving from all of these chains will be bridged to Oasis, because like on Oasis, there's a token wrapping, private token wrapping system where basically our funds can be private and cannot be tracked. And all of the funds, we can track it easily on Squidl. And if you want to like collect your funds privately, you can just using one button to make it private, and all of this will be transferred to Oasis. And from Oasis, you can transfer it everywhere, and people cannot track your real wallets. Yeah, so this is how Squidl looks like. This is the UI. So we are on the web right now. We are still on beta. And yeah, this is how it will look like for the people that open the links. It will be only QR. So every time they refresh the page, it will giving you like different address, because we are using like stat address system. So everyone will transfer to different address each time. So there's no way for people to track how many people that transfer to you, or like what is the address that transferred by other people. Yeah, and this is like our experience when we went to like it's Singapore, and we won the hackathon, became one of the finalists with Squidl and Oasis protocol. And yeah, maybe tonight to like give you like more things how we can think of the idea. Maybe I'll share about like how we can come out with the idea of like Squidl. So basically, this is one of the structure or like method that we are using to make the Squidl as a product. So first we found a problem, right? There's a lot of problems that we found if we are want to receive payments. It's really hard for us to like remember our address. If we want to get payments from someone, we have to open our MetaMask or our wallets and copy it, and we have to make sure. Like that's a really big problems. And even we are buying ENS is like one of the solutions, right? But using ENS, it's hard to make it private, because like once people know you what is your ENS, they can check easily how much money you made, how much assets you have in your wallets, and that's not the thing that we want. And the other payment is like, because like we are a company or like even individuals, when we want to receive payments, we have like clients that understand Web3 or crypto, they want to transfer with USDC or USDT. And we have also like someone that maybe like our friends that they don't really know crypto, but they have like credit card, they have bank transfer, and it's hard for us like giving like each different, this is like our bank account number, this is like our address. That's all the complexity. We want to solve it into like one problem, one solutions, where to everyone, either they know crypto or they don't know crypto, they know transfer with credit card or like using like MetaMask, we only give them like one link that unified all of the payments. Like that's the problem that we found. Then we narrow it, what is like the core problems. The problem is like we want to solve the payment system. So then we think of the ideas, right, how we can solve these problems. And how we solve it is basically we are getting all of the chains, all of the payments, right, through all multiple chains. We support it all, right? And we also support credit card payments also using like Bangsa. Bangsa is like a on-ramping system. And with these solutions, we basically solve the problems. And to make it private, we are using Oasis as the private blockchains. Like that's how Oasis can really support our solutions. And that's it. That's how we found out with the Squidl based on our research on the problems, and we narrow it down to solutions, and we choose what is like the most logical way to solve these problems. And this is another method that we are using to make the UI. And if you can see, like our UI is, we are trying to make it like mobile first, so it's mobile responsive right away, so people can use it in mobile, people can use it in websites, and it looks really simple and seamless. And yeah, I think that's it from me. Let's connect. If you want to connect with me and ask me, or maybe about Oasis or about Squidl, you can chat me through on Instagram or on my X. Thank you.